So today we're going to be exploring the science behind climate change. In this presentation, we're going to be going over greenhouse gases, feedback loops and their functions, and the basics of human impact.
So first we want to go over what is climate change. So climate change describes a change in the average conditions such as temperature and rainfall in a region over a long period of time. NASA scientists have observed Earth's surface is warming, and many of the warmest years on record have happened in the past 20 years. So now we can go over some brief history of climate change. The term global warming was first coined in 1824 by the French physicist Joseph Fourier. Research relating to carbon in the atmosphere can be dated back as far as the early 1800s, but there weren't many widespread actions to prevent it until the 1980s. In the 80s, mainstream media started to cover climate change, and the general public learned and agreed about the issues of climate change. By the late 80s, the Intergovernmental Panel on Climate Change, IPCC, formed to collect, research, and assess the damage and risk of climate change.
All right, so now we can look more into feedback loops. So feedback loops are the process whereby a change in the system results in an alarm, which will trigger a certain result. So to look more into that here, so when the environment, specifically the worldwide carbon system, are balanced in equilibrium and the interrelationships are balanced, feedback loops are not necessary. It's only when something in the atmosphere, specifically the amount of greenhouse gases and carbon dioxide, are imbalanced, that feedback loops are necessary. So there are two main types of feedback loops surrounding the issue of climate change, and that is positive feedback loops and then negative feedback loops. So positive feedback loops, put simply, are driving the problem and are perpetuating the imbalance in the environment, whereas negative feedback loops are encouraging that equilibrium and the balance. So to look more into those individually, positive feedback loops can be described as because there is more, there is more. So a really good example for this is looking into the cycle of water vapor. So greenhouse gases and the increased production of those is heating the atmosphere. And the heating of the atmosphere leads so that oceans, rivers, lakes, bodies of waters are producing water vapor. The water vapor itself is a greenhouse gas. So the more greenhouse gases there are, the more water vapor, the more water vapor, the more greenhouse gases. It's a never-ending cycle. But the negative feedback loops can be summed up as because there is more, there is less. So this is kind of lessening the problem. An example of this could be looking into cloud movement and thickness. And so the way that the height and the thickness of clouds can prevent solar radiation, which can also prevent further climate heating. So that's an example of what a negative feedback loop could be.
What are greenhouse gases? The greenhouse effect is a natural warming of the Earth that results when gases in the atmosphere trap heat from the sun that would otherwise escape into space. If you think of the atmosphere like a blanket, when you're under your blanket for a really long time, it gets really warm because that heat is trapped. The same thing happens with the atmosphere and our planet. So now we're going to go into a little bit of why humans are causing the accelerated change of the climate. So a huge argument that you see these climate deniers use is, oh, the Earth is just cycling through its natural cycles. It's the climate always is changing. It's normal. It's natural, when it's really not. And we see this in this graph, right? We're looking at the global temperature change over the years from the 1900s to the late 2000s. You can see that when you're only taking natural factors, it's kind of staying the same. Of course, it's going to be up and down for a few years. That's just how it is. But it's pretty much staying the same. But when you're factoring in these natural and human factors, the graph starts to spike drastically, right? And we can map this out from the point of the Industrial Revolution onwards. It just starts to fly up. And so there are kind of three main things that are causing climate change. You've got land use changes, you've got cement production, and you've got the burning of fossil fuels. But the good news and bad news to a certain extent is individuals do not bear the burden. An overwhelming rhetoric of what you hear when you're talking about environmentalism and you're talking about climate change is that you need to use a metal straw and you need to go vegan and you need to not use plastic bags or anything. And in reality, to be blunt, that is not going to help the climate crisis as much as solving systemic change or influencing systemic change. Because as fantastic as it may be to kind of maybe direct the flow of some of those single-use plastics going towards landfills, they're not the ones causing a huge part of this climate crisis, right? We just talked about how those big three are causing those. And when you look into the grand scheme of things, this graph is illustrating 100 climate culprits that are theorized to cause 70% of our global emissions. So when you've got these only 100 companies, you can see them, they're all listed right there, that are causing an overwhelming majority of carbon in the atmosphere. It is not fair, and it's propaganda. Actually, there's a long history of these fossil fuels companies pushing this individualized propaganda to divert the attention from their own unsustainability.
All right, so that's coming to the end of our presentation here, but these are some questions you can go over in your advisories based off of what we went over. So what is something new that you learned? What's something that surprised you? And what is something you want to learn more about? That is the end of the presentation. We'll see you next week. Thank you.
Thank you.
Thank you.